In session 43 here, we're going to be taking a look at simultaneous equations. What are simultaneous equations? Well, they're two different algebraic equations that occur at the same time, and what you're trying to do is find a solution, an answer, such as an ordered pair, that'll work for both solutions or for both equations at the same time. Before we take a look at simultaneous equations with variables, I wanted to take a look at two straightforward equations that we have here and analyze it just a little bit. First of all, we have 6 equals 24 over 4. Well, that's very straightforward. We can see that those two are equal to each other. Well, in our second equation, we have 4 equals 4. That's also very straightforward and easy to see. Now, one of the things that we had earlier on, one of the statements that we had about solving equations was that whatever you do to one side of the equation, you have to do the same thing to the other side of the equation to keep them equivalent to each other. So for example, if you were to add something to the left side of an equation, you'd have to turn around and add the same thing to the right side. If you're going to multiply the left side of the equation by a particular value, you have to multiply the right-hand side of the equation by that same value. Well, let's take a look here what happens. What would happen if we would take this second equation, 4 equals 4, and add it to the 6 equals 24 over 4? Well, the way you add equations together that are occurring simultaneously is you take the left sides of the equation and you add them together, and you take your right side of the equations and add them together. Well, in this case, if we take the left side, I'm going to be adding a 4 to the 6. Well, I also have a 4 down here on the right side because these two are equal to each other. Now I'm going to turn around and add the same value, 4, to the right-hand side of the equation. So as long as to my first equation here, as long as I add the same value, 4 to the left, and turn around and add 4 to the right, I have created an equivalent equation that is not different in its answer to what I had to start with. But if you take a look here at the original equation, 6 equals 24 over 4, the left side of the equation is a whole number, counting number. The right-hand side of the equation is a fraction. Maybe it would be more helpful if we were going to combine these two equations together if we could somehow create a fraction on the right-hand side that we could then add to an existing fraction. That would get us a step closer toward combining those two values together. What if we were to go ahead and in place of the 4 down here on the right, let's just go ahead and erase this 4, and what we're going to do is replace it with a value that equals the same thing as 4. What I'm writing here is 16 over 4. Well, if you took 16 and divided it by 4, what's your answer going to be? Well, it's 4. So my question to you is this equation 4 equals 16 over 4 accurate? Well, of course it is. Does it equal the value of the original equation that I had to start with, which was 4 equals 4? Well, sure it does. So by changing the 4 on the right-hand side to 16 over 4, I have not changed the accuracy of this equation. 4 on the left still equals 16 over 4 on the right. It looks a little bit different, but it's still the same value. Now, if I wanted to go ahead and add these two equations together now, it's a little bit more straightforward. Okay, I'm taking my 6, the left-hand side, and I'm adding 4 to it. 6 plus 4 is 10. So after I've added 4 to the left-hand side of the equation, I now have 10. Well, I now need to add 4 to the right-hand side of the equation. But what we've done here is we've rewritten 4 as 16 over 4, which has the same value. What is 24 over 4 plus 16 over 4? Well, that's 40 over 4. Does 10 equal 40 over 4? Yes, it does, because if you take 40 and divide it by 4, you'll find out that your answer there is 10. So the purpose of this initial screen here is to show you that you do not have to add the exact same numerals and the exact same arrangement to both sides of the equation to keep it in equivalency. You have to add the same value to both sides of the equation. There's nothing that says that if you add a value of a digit of 4 to the left-hand side that you have to add a digit of 4 to the right. You just need to add something to the right that has the same value as 4. And in this situation here, 16 over 4 works because it gives us the same denominator that we have up here in our original equation. Now let's take a look at simultaneous equations that include variables, and it's going to be making use of the same concept that we just took a look at on the previous screen. Our first equation says x plus y equals 95. Our second equation says x minus y equals 25. Now what we're going to do is we're going to take these two equations and add them together. Well, if you take a look down here at the second equation, it's telling us that x minus y has the same value as 25. So the question is, if I wanted to add these two equations together, would I have to add a 25 to the left-hand side and then a 25 to the right-hand side? Well, that would be accurate. It would be one method of doing it. However, it's not going to get us any closer to what our goal is here. Because the main goal when you try to add simultaneous equations together, you're trying to do it in such a manner that will end up canceling out one of the variables for you, so that you're then just left with one variable, and that you can then solve that resulting equation for that one variable. What if instead of adding 25 to the left side and 25 to the right side, what if I said, well, let's add 25 to the right side, but let's add x minus y to the left side? Can we do that? X minus y isn't the exact same appearance as 25, but can we add x minus y to the left? We can, because the second equation here tells us that x minus y is the same thing as 25. They both have the same value. So if I come here to my left-hand side of the equation of x plus y, and then I add to it x minus y, that's the same thing as adding to it 25. Because remember, x minus y equals 25. So then let's go ahead and simply combine these. We have x plus y on the left, and what we're adding to it is x minus y. Well, first of all, x plus x is 2x. Then you have a y plus a minus y. Well, a y plus a minus y cancels each other out to a 0y. And 0y is just simply 0. So when you take a positive y and add it to a negative y, or a minus y, they will cancel each other out. So our y's are now gone from our left side of the equation. Then on the right-hand side of the equation, we're taking the 95 plus the 25, and that's giving us 120. So you can see here, by adding a value of 25 to both sides of the equation, we are now left with 2x equals 125. But the value for 25 that we added to the left-hand side was in the form of x minus y. Now we simply solve it for x. 2 times x equals 120. How do we get the x by itself? Well, right now it's being multiplied by 2. So what we're going to have to end up doing now is dividing both sides of our equation by 2. Well, 2 times x divided by 2 is just simply x. And then 120 divided by 2 is 60. So what we found out at this point is that the value for x that'll work in both of these equations is 60. Now what we need to do is to find out what the y value is. Well, to find out what the y value is, we need to plug our value for x back into our first equation here. So let's go ahead and rewrite that. When x is 60, we're now going to have 60 plus y equals 95. Okay. At this point, then we solve it for y. Well, what's going on with the y? It's being added to a 60. So in order to get rid of that 60 that's being added to it, we now need to subtract 60 from both sides of the equation. Well, what is 60 plus y minus 60? Well, these two 60s cancel each other out. A positive 60y plus a minus 60, or excuse me, a positive 60 plus a negative 60 is just going to be 0. And then you're left with 0 plus y, which just is the same thing as y. So our left-hand side of the equation is y. Our right-hand side, 95 plus a negative 60, is going to be a positive 35. So let's go ahead and stick that back into the original equation. We found out that our x is 60, and we found out that our y is 35. Let's double check our work. Put in the 60 up here for x. 60 and then y, 35. Does 60 plus 35 equal 95? Yes, it does. Put it into the second equation. X is 60, y is 35. 60 minus 35, does that equal 25? Yes, it does. So what we've done now is we've found out the values for x and y that will be solutions to both of these equations. And if we were to write them as an ordered pair, remember in your ordered pair, your x value comes first and then your y value. So our ordered pair would be 60, 35. That is the solution to these two simultaneous equations. Quickly then, as a review, simultaneous equations. Two equations that occur together to which you are trying to find the solution, an ordered pair, that works for both equations. And then the particular method for solving simultaneous equations that we addressed in this lesson was called the addition method. And that's just simply a method of solving simultaneous equations whereby you take the two equations and add them together. And in order to add them together, you take the left sides of the two equations and add them together. You take the right sides of the equations and add them together and then set them equal to each other and start solving those equations based upon the variable that's left. So then, that's simultaneous equations using the addition method to solve those equations.